Hello everyone! I'm Mariel Miranda de Souza, PhD student Civil Engineering at the Universidade Federal de Viçosa, and in partnership with co-authors José Maria Franco de Carvalho, Gabriela Moreira Silva, Leonardo Gonçalves Pedrotti, Guilherme Jorge Brigolini Silva, and Ricardo André Fioroz Peixoto, I come to present a brief summary of the research methodology and bibliometric analysis used in the work, Bibliometric Analysis of Limestone Calcined Clay Cements, LC3. A bibliometric analysis can help in understanding the interests of a group of articles, such as discovering the most relevant articles in the area, the main publication sources, the most relevant and influential authors, the main countries and institutes in the area, the most used keywords, the most relevant topics and subjects. Furthermore, it aids to recognize research gaps and emerging trends, offering valuable insights for future studies. To this end, in this work, the Scope Search platform was used to carry out a bibliometric research with previously selected keywords related to the topic limestone calcined clay cement. Bibliometric analysis was carried out using VosViewer and Bibliometric software, which analyze work metrics and generate data maps. The Pajek software was used with the aim of improve the quality of the maps, previously generated in the VosViewer software. Initially, a keyword search was carried out in Scope's website, all documents found were selected, and CSV document was exported with all document information. In the VosViewer software, a map was created with the file type based on bibliographic data, with source type from bibliographic database, such as Scopes, and selected the Scopes tab for search for downloaded CSV document. The type of initial analysis was bibliographic coupling, with a document analysis unit. Documents with at least one citation were selected. In the new tab, you can check the 10 main documents. When finished, the unconnected items were not deleted. To improve map visualization, each item of the map was reorganized with the help of Pajek software. For this, the map file generated in VosViewer was saved using the Pajek tab, in addition to the partition and vector files being saved. When opening the Pajek software, in the network line, the map document was opened by clicking on the folder symbol. The same procedure was performed on the partitions and vector lines. The checkbox for the partition and vector lines were selected. To then edit the map by clicking on the pencil symbol for the networks line. With the manual adjustment page open, in the Move tab, the X, Y, and radial axes were unfixed so that all points could be moved freely. In the Layout tab, the model was chosen, circular random. And again, in the Layout tab, the model was chosen, energy, Kamara Kawaii, optimized inside clusters only. This way, documents appear grouped by clusters. To facilitate visualization, the vector intensity box was unchecked. With the smaller documents, the clusters were repositioned by clicking with the mouse next to the groups and moving them so they were isolated from each other. By clicking on a point, a single document can be repositioned rather than an entire group. After the necessary adjustments, the changes to the document were saved in the Networks line. When returning to the VosViewer software, the new document adjusted in the Pajek tab was opened, in addition to the unchanged partitions and vector versions opened. With the final adjustments, the map was saved as an image. After creating all maps, the results were analyzed and discussed considering data from documents, main publication sources, main authors in the area and their connections, countries that published the most in the field, in addition to the most frequently occurring keywords, most studied topics, gaps, and trending topics. Thank you for your attention. I leave the group contact information and mine, as well as the invitation to read the full article.